Hello everyone. Welcome to the solution of LeetCode problem 994 named rotting oranges. In this problem, we are given a matrix grid of n by m and there are basically three values. 0 represents the empty cell, 1 represents the fresh orange and 2 represent the rotten orange. Now, in every minute, every fresh orange that is four directionally connected to a rotten orange becomes rotten. And we have to return the minimum number of minutes that must needed until no cell has a fresh orange. And if it is impossible, then we have to return -1. Now let's understand the first example. Here, at the minute 0, initially this is rotten and the rest of the oranges are fresh. So in the minute 1, its two neighboring oranges become rotten, and the minute 2, these two oranges will become rotten, and in the minute 3, this orange become rotten, and in the minute 4, this final orange become rotten. So in total, there are 4 minutes we needed to make all of the oranges rotten. So we have to return 4. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we will use the breadth first search technique. So basically the intuition is in the BFS, we will visit the grid into a level by level. So suppose this is our initial state and we will visit the grid by level. So here, according to the problem statement, for any of the cell, we can go either up, down, right, or left. So in the BFS, basically we have to first check how many rotten oranges we can have till now. So initially we have only one rotten oranges, which is this. So we have to start the BFS here. So from this rotten orange, we can move either right, down, up, or left. So here, up and left, we cannot move. So in the first minute, we can infect these two oranges, right and down. So after that, we have 3 rotten oranges. Now we have to recursively call the BFS function into these rotten oranges. So from this rotten orange, I can go right, up, down, or left. But up and left is not possible because left one is already rotten and the up is out of bound. So we can visit or we can infect the right orange and down orange. Similarly, for this orange, we can go down, left, right or up, and all of the 4 moves is invalid because right and up is already infected, but down and left is not available. So from this orange, we cannot go anywhere else. So in total, in the minute 2, there are 5 orange which is infected. Now let's make the BFS from this orange, and we can go down, right, left, or up, and right, left, and up is invalid, so we will go to the down. So let's make this orange rotten. So now there are 6 orange rotten. So finally from this rotten orange, we will go to the right and make the final orange, which is rotten. Now we have seen that we have completed the algorithm and all of the oranges has been rotten. So in total, there are 4 minutes we have took. So So this is how basically we're gonna solve this problem by using the BFS or level by level ordering. And overall time complexity of this algorithm is big O of n into n. In short, let's summarize the algorithm. At first, we have to calculate in how many fresh oranges we can have. After that, we have to run the BFS from the rotten oranges and move the algorithm in 4 directions: up, right, down, and left. And we have to repetitively make the orange infected or rotten. After that, finally, we have to check, does we completed all of the fresh oranges or not? Or does we infected all of the fresh oranges or not? If we have infected all of the fresh orange, that means in this case, we have to return the time we needed. Otherwise, we have to return -1 because it is not possible for us to infect all of the orange. And overall time complexity of this algorithm is big O of n into n, where n is the number of row and m is the number of column of the grid. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named orange rotting, which is a grid as a parameter. Now we are calculating the dimension n and m of this grid, and initially our time is 0 and the fresh orange count is 0. Now we are taking a queue data structure which will store the pair I and j, which is the index of the current cell, and we are taking a direction array. By utilizing this direction array, we can go up, right, down, or left. Now, for each of the cell, we will check if the current cell is fresh or not. If it is, we have to increment the fresh counter. Otherwise, if the current cell is rotten, we have to insert its row and column value into a queue. Now, we have to run the BFS. And here, if the queue is not empty and we have still fresh orange left in our grid, we have to calculate the size of the grid, size of the queue, which is the size of the current level. And for each of the size, or we have to calculate the front element of the queue. So here, each element of the queue has two variable I and j. So the I would be the front elements index and j would be the front element index, which is front element first and second element. Now we have to remove the front element from the queue and we have to iterate into the direction array and calculate the new I and j, which is I plus direction array's first element and j plus direction array's second element. And we have to check now whether our new I and new j becomes out of bound or not. That means if new I is less than 0 or new j is less than 0 or new I is greater than or equal to n or new j is greater than or equal to m, or the current grid cell, the new grid cell is not equal to 1. In those kind of cases, we have to simply ignore or simply continue the loop. Otherwise, if the new y and new j is valid and we have found a fresh orange, so we have to make it rotten. That means we have to assign the value of 2 into the fresh orange and insert the current rotten index to the queue and decrease the fresh counter. Finally, completion of this level, we have to increment the timer. And here, after completion the BFS, if we have already left some of the fresh oranges, we have to return -1. Otherwise, if the fresh oranges count is 0, we have to return simply the time we have needed to make all of the orange rotten. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.